Hi, Calc students. So we are going to be looking at arc length of a curve in this lesson. So I'm going to share my screen and you can see the presentation. Hopefully you have your notes in front of you, can follow along as I go through the examples. So you actually had arc length in geometry and used the distance formula. Distance formula, find the distance between 2 points. Then you also found arc length by setting up ratios with the circumference of a circle and found it that way. And so it's going to be kind of the same idea. We're finding the distance between 2 points on a curve, which we call arc length, and we can find that out by setting up an integral. So in this first slide, we have the formula for arc length. And you can also have the arc length with respect to y, and that's in your notes. So we have a smooth curve. Notice it's not, doesn't have any sharp corners. If there's no breaks in the graph at all. So it's a smooth curve on the interval AB, and then this is our arc length formula. So we're going to be taking our function, finding the derivative, squaring it, adding it to 1, taking the square root, and then finding the antiderivative. So let's look at our first example. So it says, find the arc length of y equals x to the 4th over 8 plus 1 over 4x squared over the interval 1 to 3. So the first thing we need to do is find the derivative. So I'm going to grab my pen here. Let's go blue, I think, tonight. All right, so I have y. And I'm going to rewrite these just so it's a little easier to take the derivative. So this first one is 1/8 x to the 4th. And the second function turns into 1/4 x to the -2. So that's what I'm finding the derivative of. So y prime is 1/2 x cubed. And this would turn into -1/2 x to the -3. All right, so I'm going to rewrite those. So that's, let's see, I'll write it as x cubed over 2. And this is minus 1 over 2x cubed. All right, so in the arc length formula, we know we need to have the square root of 1 plus f prime squared. So one thing I'm going to do is I'm going to just do that step here. I'm going to do 1 plus, and this is my, f of x prime, all right, my derivative of this squared. So I'm going to do some simplifying here. And I have this all written out in the notes too. So if it's easier to follow that, I will scan them and post them and you can look at the worked out examples. But I'm going to go ahead and do this. So this turns into x cubed over 2 squared. Okay, and then we have this, the product of these two terms, and we have 2 of those, so minus 2 times x cubed over 2 times 1 over 2x cubed plus, we're going to have this last term squared. And when I square this negative, it's going to end up being a positive. So I'm going to go ahead and just write it as 1 over 2x cubed squared. All right, so I can do some simplifying here. These 2's will cancel, x cubes will cancel here. And so now I have 1 plus, and I'm still going to leave this in this form. Oh, I'm getting the crazy monkey pen again. And this is a 1/2 now. And plus, I still have this term. All right, so I can combine the 1 with the minus 1/2. So that's going to give me, and then at this point, I'm going to go ahead and jump a step, and you can look at the worked out notes to see this. So what this is going to turn into, I'm going to skip a couple steps here. We have 1 minus 1/2 is 1/2. And then this next term is if you can read that scrawl there, is x to the 6th over 4. And this last term is 1 over 4x to the 6th. All right, so I'm going to get a common denominator for those three terms and rewrite them. So I'm going to have 2x to the 6th. My common denominator, by the way, is 4x squared. So this turns into 2x to the 6th plus x to the 6th squared plus 1 all over 4x to the 6th. If you reorder these terms here, if I make, oh, sorry, this was x to the 6th squared. I left out my 6th. If I reorder these terms, I have x to the 6th squared plus 2x to the 6th. And that's a 6. Boy, these 6's are not showing up. Plus 1. And hopefully you can see that that is a perfect square trinomial. So it turns into x to the 6th plus 1 squared over, and this bottom, the denominator is 4x to the 6th, which would be 2x cubed quantity squared. So now I can put this into my arc length formula. Arc length is equal to the integral from, and we're going from 1 to 3. I now have this entire thing underneath the square root. So if I have, and I can put them all together, x to the 6th plus 1 over 2x cubed. I have that entire quantity squared. And so the square root is going to cancel with the squares. And so I am left with x to the 6th plus 1 over 2x cubed. And the integral is from 1 to 3. These integrals are crazy looking. And that's a dx. Okay, so I'm going to simplify. I'm going to rewrite both of these with the denominator of 2x cubed. So my arc length is still the integral from 1 to 3. X to the 6th over 2x cubed would leave me with x cubed over 2 plus, and then I have 1 divided by 2x cubed. So I'm just splitting that denominator. Dx. And now I'm at the step where I'm finding the antiderivatives of those. So the antiderivative of x cubed over 2 is 1/8. That's an 8, by the way. X to the 4th minus 1/4, or 1 over, excuse me, 4x squared. And we are evaluating that from 1 to 3. All right, and so if I do all that, and I will trust you to substitute the 3 in here and then subtract what you get when you plug in 1, you end up with, the first term I think comes out to be 88ths. I'm just going to go and write the answer because the pen is not cooperating. You should end up with 92 ninths as your final answer. Okay, so the process isn't too bad. Some of the parts that are a little slow are where you need to square whatever they give you, add it to 1. But you're trying to get it down usually to something where you can take the square root of a squared term, like we had those nice this canceled, the square canceled with the square root. And so it was a lot easier to find the antiderivative. So that's what we're going to look to try to find. All right, let's look at example 2. So this time, find the arc length of y equals the natural log of cosine x over the interval 0 to pi over 3. All right, so this time we have y prime is equal to, it's a natural log function, so 1 over cosine x. And then we need to take the derivative of cosine, which is negative sine. So y prime is equal to negative tangent x. All right, so remember we're going to have to do 1 plus f prime of x squared. All right, so I know I'm going to have then, when I plug in my negative tangent, I'm going to have 1 plus negative tangent of x quantity squared. And negative times negative is positive, so this turns into 1 plus tangent squared x. And hopefully you recognize that 1 plus tangent squared x is a trig identity, and it is secant x, or excuse me, secant squared x. All right, so we're going to set up our integral. Our arc length is going to be the integral from 0 to pi over 3. And we have the square root of, and remember, I already took care of our 1 plus, so 1 plus tangent squared x is secant squared x. So we have the square root of secant squared x dx, which is going to be the integral from 0 to pi over 3 of secant x. And this is one we don't find the antiderivative of very often, so you might want to look that up. You should have a table of all your integrals. So the antiderivative of secant is ln absolute value secant x plus tangent x. And I'm evaluating that from 0 to pi over 3. All right, so the first time I put in pi over 3, I have the natural log of secant of pi over 3 is 2. The tangent of pi over 3 is square root of 3. And then we have minus the natural log of secant of 0, which is 1, plus tangent of 0, which is 0. And so this is the natural log of 1 is 0. And so we are left with the natural log of 2 plus the square root of 3 for our final answer. All right, our last example is one where you need to use a calculator. But if we started out same way, we would find y prime. And you might want to think of these sometimes, sketch a little picture of what's going on. So a natural log graph, oops, let's go back. I forgot to get my pen. A natural log graph, remember, has a vertical asymptote at x equals 0. It crosses the x-axis at 1. So it's going like this, and we're trying to find this arc length from here, just this part here, over to where we get to 5. So 2, 3, 4, 5. So I'm trying to find how long is this part of the curve here between those 2 points. All right, so we'd get y prime is equal to 1 over x, and y prime squared then would be equal to 1 over x squared. So then our integral to find our arc length is the integral from 1 to 5 of the square root of 1 plus 1 over x squared. Right? We've already squared it, dx. So you could sit and play with that and try to find the antiderivative, but it's one that you need to use a calculator for. So you can pause the video, grab the calculator, check it out. You should see that this is about equal to 4.367. All right, so our last slide just says what today's assignment is. It's called arc length practice. I think there's 4 problems. I think there's 1 free response and then the others are multiple choice. It's on the AP Classroom website. So you guys can go ahead and get going on that. Just email me if you have any questions. And again, I will post the completed notes if you didn't get all that I went through on this. So good luck and I'll see you in class.